Hi everyone, this video is designed to help you with assignment number 10 in your resource pack. And what you're going to find is that our last video talked about the basics of acids and bases, what they are, and how we can use the pH scale to help describe them. In this video, what we're going to be looking at is what happens when we combine acids and bases together in this process called neutralization. And hopefully that word neutral is going to key you in on what's going to happen when acids and bases get combined in different amounts. So what we said before is that acids produce H plus and bases typically contain OH minus. So if we pour those two things together, let's say in some sort of experiment, we're going to get an H plus ion mixed together with an OH minus ion. And if I stick those two things together, I get HOH, which, folks, is just another way of writing H2O. And you all know that pure water is completely neutral. It's got a pH of 7. So let's take a real example of an acid from table K, HCl, and combine it with a base from table L, maybe KOH. What we're going to see is that this procedure happens, and it just happens to produce another product. Here's the H plus from HCl that's going to make it acidic, and the OH minus from KOH that makes it basic. When those two things hit each other, we do produce H2O. And then our second product is going to be whatever salt gets left over. In this case, we've got potassium and chlorine, which can combine to form potassium chloride. This is called a neutralization reaction because we've taken something that was once very acidic and very basic, and by combining the two together, created neutral products. And we can take advantage of the fact that acids and bases neutralize one another in an experiment called a titration. And the reason titrations are important is because they allow us to figure out unknown concentrations. Now, you may have a sample of clear liquid in front of you, and you may have figured out that it was an acid by using some kind of indicator, but you don't know how concentrated that acid is. Is it a 0.01 molar solution, or is it a 10 molar solution of acid? The only way to figure that out is to try and cancel out all of the acid using base. Because if you know how much base it takes to neutralize the acid, you'll have an idea of how much H plus was around in the first place. So what a titration does is it takes a known amount of a particular substance, either an acid or a base, and it uses its opposite to neutralize it. So let's walk through an example where we have some unknown acid and we're trying to neutralize it using a known concentration of base. So let's say I made 0.5 molar KOH. I know that this solution contains a certain amount of OH minus ions. And in here, I've got, let's say, 20 milliliters of HCl. So I know it's an acid and I know it's HCl, but I just don't know how concentrated it is. By dropping KOH in here, what I'm really doing is adding OH minus ions into the solution. And every time an OH minus finds an H plus, it neutralizes it out. The more OH I add, the more H plus I'm going to be able to neutralize. So I'm going to keep adding OH and adding OH and adding OH until all of the H plus is neutralized. How are you going to know that it's neutralized? Well, one of two ways. You've either got a pH probe and you keep adding OH minus until you hit that magic number 7, or you use some kind of indicator that's going to change color somewhere around pH 7. So you would see a new color appear. In lab, you guys used phenolphthalein and saw that as soon as that solution turned a light pink, you were done. That means all of the OH minus had canceled out all the H plus that was available. So how do you use that information? Well, there's a titration equation listed for you right on table T. And if we analyze this equation, what we see is that in order to neutralize something, we need to know about how much H plus was around, so its concentration, what volume of acid we had. Did we have 2 drops or did we have 2 gallons of acid to neutralize? We need to know about the concentration of our base, so how many OH minuses we were adding, and how much base we had to add. Did we have to add 2 drops or 2 gallons? So using this particular equation is going to help us figure out what our unknown concentration might be. So let's say in this figurative experiment, we ended up having to add only 10 milliliters of our 0.5 molar KOH. What you're going to notice for titration problems is that the word titration is probably going to show up, and you're going to be given data on both an acid and a base. When we calculated molarity previously, all you needed to know about was one substance, and that substance didn't even have to be an acid or a base. So in the case of titration problems, you've got 2 big clues to look for. 1, the word titration, and 2, the presence of 2 different substances, one an acid, the other a base. So in this case, I know that I had 20 milliliters of acid. You don't have to convert to liters for titration problems. I didn't know the concentration, so I'm going to leave that as my X. That's going to equal the concentration of my base, which was 0.5 molar, and I had to add 10 milliliters of that base in order to completely cancel out all of the H+ ions that were in solution. So here's again where you can let your calculator take control. In order to solve for X, I need to divide both sides by 20 to get X alone. So into my calculator, I'm going to enter 0.5 times 10, and then divide that number by 20 to get to 0.25 molar. And that tells me that this acid was half as concentrated as the base. And that makes sense. I had 20 milliliters of acid, and it was completely canceled out by only 10 milliliters of base. So this answer seems logical, and we got there by using the titration equation and this fact that acids and bases, when mixed together, cancel one another out in a neutralization reaction.